Before finishing this introductory course on special relativity, let's talk about one last paradox. Assume there's a hoverboard that is traveling at relativistic speed at a 45-degree angle to the right and down. In its path there is a ceiling with a hole in it, and the board wants to go through the hole. The size of the hole is h, and the length of the board is L, where L is a bit larger than h. From the whole point of view, because the board has horizontal component of the velocity, it will be length contracted. This way it will fit in a hole and pass through it. From the point of view of the board, because it is the whole ceiling and the hole that are moving at a 45-degree angle up and to the left toward the board, it is the hole, the one that is length contracted. Because of this, the board will not pass through the hole. So, what happens here? Does it make it through or not through the hole? It is a bit more complex paradox, this one, than the previous ones, because it is a two-dimensional problem. To solve it, I will define events and try to find their coordinates in both reference frames. From the point of view of the ceiling and the hole, the trajectories of the tip and tail of the hoverboard make those 45 degrees. Let's define event A, that where the tail of the board passes the left of the hole, and event B as that where the tip of the board passes by the right of the hole. If these two events are simultaneous, let's say they happen at t equals to 0, one happens at x equals to 0, and the other x equals to h, the size of the hole, which happens to be the length contracted of the board. Now I'm going to move to a reference frame that moves horizontally to the right at beta. From this reference frame, I will see the board move vertically down and the hole move horizontally to the left. Let's use Lorentz transformations to find the coordinates from the boards from this particular reference frame. So in this particular reference frame, the board is not contracted in the horizontal direction, but the hole is. So let's grab Lorentz transformation equations and find these coordinates of events A and event B as seen from this new reference frame. X prime A is 0 and T prime A is 0. X prime B is gamma times xb minus beta tb, so gamma times xb. Also, T prime B is gamma times tb minus beta xb, so minus gamma beta xb, which is minus gamma beta h. This is a negative time. This means that this event happens earlier in time than event A. What does this mean? Well, to understand this, let's draw the trajectories of both sides of the board and both trajectories of the ends of the hole. If event B occurs earlier, this means that the board does not come horizontally as seen from this reference frame. It comes tilted. This helps compensate for the length contraction of the hole. Also, now you can jump to the reference frame of the board. Let us draw the trajectories of the two ends of the hole. They make a 45-degree angle up and to the left. The board here is horizontal. You are on the board, and again event B takes place before event A. Here it is the hole and the hole ceiling that comes at an angle with respect to the board. This compensates for the length contraction of the hole, and the board makes it through the hole. Remember, space and time are not rigid anymore, but flexible. Not rigid rules that define distances, not rigid tick-tocks of synchronized clocks.
People assume that time is a strict progression of cause to effect, but actually, from a non-linear, non-subjective viewpoint, it's more like a big ball of wibbly-wobbly, timey-wimey stuff.